increased the fixed window size from 0 to 2 while, and I see the similarity, these two values change. You can see here from 2 to 4, the similarity value is increased, then they will decrease. Based on this figure, I can see that 4 is the best, the appropriate window size to for the co-request model to detect the relations about different concepts. It is better for the specificity and the sensitivity. Then I perform some complex text. These text files are from online source. For example, one is about Wikipedia about the University of Florida, one is about China, and there are several about operating system description. Many these texts are very complex and from the online source. Here I use the relation associated model as the standard output and use the co-request model and the semantic feature model to match the relation associated model. So the value of the relation associated model are also 1 in these two cases. Based on this test, I can see that the co-request model performs better for the concept detection, but doesn't do well in the topology established. The reason is that the output of the co-request model is a directed graph, not a directed one, so it has less value in the topology established similarity. But the semantic feature model can do well in both. And the effective of the semantic feature match model, it depends on the semantic features you get. If the plaintext, the original topology of the plaintext is based on the tree or a tree-like topology, semantic feature match model is very effective. For example, in test 3, test 7, test 4. Then I will evaluate the real gap between the relation associated model and the original topology. In the previous test, you can see that I used the relation associated model as the standard output, but how the relation associated model is the same as the real case. What I mean is that the original case. Here I only use the 3 tests because establishing the real context is very complex. From this text, you can see that the relation associative model has high value, more than 0.9 for the test 1 and test 2. For test 3, it has low value. For the topology established similarity, you can see that for test 1, test 2, it has very high value, but for test 3, the value is still low. From these two figures, you can see that the relational associative model is almost the same as the original topology, but the effectiveness of it depends on the relation list you get. If the relation lists you get from the plaintext are very accurate, this model can get very accurate results. But if can't, the result will like text 3. It has not very high major concept list similarity and topology established similarity. So here is the total experiments I performed about this cross project. Then I conclude this presentation. In this presentation, I talk about the problem definition. I also use one case study to show what the problem is and how to resolve this problem from the plaintext to the topology. Then 3 models and the related topology construction methods I evaluate here. I also develop 2 evaluation metrics. One is the major concept list similarity, the other one is topology established similarity. Based on the experiment, I can see that the relation associative model is the most important, efficient one. Its effectiveness depends on the relation list you get. The semantic match model is better for tree or tree-like topology, and the contrast model is easy for implementation. The contrast model is also easy to use, but it has the specificity and the sensitivity issue, so you have to choose the appropriate window size. Based on the relational sorted model as the standard, we get 0.7 major concept least similarity and 0.4 relation established topology similarity for contrast model and 0.69 and 0.53 for the semantic match model. We also evaluate the real gap and the sensitivity and specificity of the contrast model I've already described before. Here, the software of this project is released from GitHub. Here is the link you get. If you want to use this software, you can just git clone this link and then use it. It is easy to use and easy to understand because I add some comment here and you can modify it. However, if you want to use for some commercial uses, this can't be done. Thanks. Here are the 2 emails I often use. You can contact me with these emails for the problems, for some detailed implementation or detailed things about the method, the implementation, the experiment. You can see the results. Okay, thank you.